Today we'll be going over the remainder theorem. A very useful and pretty compact formula in algebra that can save you a ton of time on a variety of tasks you might see in your homework and your schoolwork, on your tests, your quizzes. It's just a real time saver and great for solving a whole ton of problems. So what is the remainder theorem? All right, what is it at its core? Well, basically it says if you've got a function f of x and you're dividing it by x minus a, right? The remainder you're going to get from that division, the remainder is going to be equal to f of a. So after you've divided f of x by x minus a, that remainder, the one term that you can't fully fit in, is going to be equal to the original function, but plugging in this a term you have in this term. You may say, well, why is that useful? Why would this ever be useful for anyone whatsoever? Right? Well, say I was given, x squared minus 6x plus 9, right? And I was asked to divide this by x minus 2. I'd have to do some long division, and it wouldn't be bad, but it certainly wouldn't be good. But it would be really bad if this was bigger. If this had like x to the 6 plus so on and so forth, it'd be really painful for me to divide those all out and find, the remainder that way. With this, I can just plug in f of x at 2 and evaluate it just how I normally would and get the remainder. So we plug in 2, we do the math, we get 4 minus 12 plus 9. That's 13 minus 12, or 1. So the remainder of this is 1. And at first you might say, okay, it's great whenever I'm dealing with remainder problems. That's pretty cool. But why would I ever need to know that? Well, there is something pretty interesting that you can also do with this that really comes in handy. So let's say I'm given a huge quadratic, right? Or not a quadratic, a polynomial that has like x to the 10, right? And so on and so forth. And I'm given like, say, x minus 5, and I'm asked, is this a factor of this polynomial? And determine if it's a factor, I have to take this giant polynomial, I have to divide it out, doing long division, which is painful. And even if I use shortcuts, it's still going to be painful. And then I have to see, just maybe does it fully divide out? Because even if I do that and I get a remainder, it's like, okay, no. It's still a lot of work. But the remainder theorem comes in clutch here. It makes the job so much easier. And why is that? Well, if we divide this function by x minus 5 and get no remainder, a remainder of 0, right? That means the function is fully divisible by x minus 5, right? So that means x minus 5 is a factor of f of x if the remainder is 0. Well, you know what? We can use the remainder theorem. We can plug in this number, this a, into x and say, okay, f of 5. And if f of 5 equals 0, then x minus 5 is divisible by this polynomial. If f of 5 does not equal 0, well then x minus 5 is not a factor of this polynomial. And see, that's when the remainder theorem really shines. It's checking to see if certain terms are factors of a very large polynomial. Because with the remainder theorem, you don't have to deal with messy division. You don't have to deal with weird things all the time. You can just plug in the associated term into your polynomial, find out if it equals 0, and then you'll instantly know, is it a factor, is it not a factor? And that's very clean and precise, and that's why I use the remainder theorem all the time for stuff like that, which are common problems you often do see. So that's the remainder theorem. I hope that helped, and I hope you have a great day.